In this video, we're going to be looking at a couple of different theorems that we get from intersecting lines and circles. So, first important thing to notice when we have intersecting lines and circles is that if two non-parallel lines intersect a circle, there are three places where the lines can intersect. So first we see our lines can intersect on the circle. Then we see the lines can intersect inside the circle. And we see that the lines can intersect outside the circle. And so we get different ways that we can actually find these angles with the following theorems. We've already learned about on the circle. We know that this angle would be half of the measure of this arc. But now this next theorem tells us how we can find the ones for inside the circle. And it says if two chords intersect inside a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. And so let's go through that with this diagram here of the different equations that we can get. So first, if we were wanting to find the measure of angle 1, what this theorem is telling us is that the measure of angle 1 is going to equal to 1/2 the sum of the arcs intercepted by the angle. So we see angle 1 intercepts arc AB plus the arc intercepted by its vertical angle. So remember, the vertical angle is this angle right here, and its intercepted arc is DC. So angle 1 would equal half of measure of arc AB plus measure of arc DC. And when we're doing these in these problems, I am going to write this in this format to make it a little bit easier to solve. So measure of arc AB plus measure of arc DC divided by 2. And then similarly, if I was wanting to find the measure of angle 2, it would equal the measure of its intercepted arc, which is BC, plus the measure of the vertical angle intercepted arc, so AD, divided by 2. So that's for those chords that intersect inside a circle. We can also find the angles that are intersected outside the circle. So if a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. And so we see we have three different ways this could look like. This first one, I have a tangent intersecting with a secant outside the circle right here. And what this theorem tells us is that this measure of angle 1 is going to equal to the difference of the measures of the intercepted arc divided by 2. So you always want to take your bigger arc. So this bigger arc is going to be BC minus the smaller arc AC divided by 2. And we'll see that's going to be the same case with these other two cases. It just looks a little bit different. So for angle 2, I see these are two tangents that are intersecting at a point, and so this would be that the measure of angle 2 is equal to my bigger arc, which is going to be DEF, minus my smaller arc, which is DF, over 2. And then when I have two secants intersected, I see the same thing. So it's going to be the measure of my bigger arc, HJ, minus my smaller arc, which is GI, divided by 2. So mainly the important thing to remember here is that the angle is equal to big arc minus small arc divided by 2.